All right, folks, there was a request to record problem number 5 on the homework due tomorrow. So this is this problem way down here. Remember, we let me refocus this. Sorry, folks. Let me put the lamp on. Does this help at all? I think it does a little bit. Remember that we scratched out number 4. So problem 5 says, we hear that listening to Mozart improves students' performance on tests. Maybe pleasant odors have a similar effect. To test this idea, 21 subjects worked 2 different but equivalent paper and pencil mazes while wearing a mask. The mask was either unscented or carried a floral scent. So we had unscented or floral. And they give me a table that has the times with both masks, and obviously smaller times are better. And the question is, do the data provide convincing evidence that the floral scent improved performance on average? Okay, well, let's take a look. So first thing I need to do is tell me this is a 2-sample. No, it is not a 2-sample t-test. See, I was about to make a mistake here. This is a paired t-test. And the reason I know it's a t-test, of course, is I do not know the standard deviation of the population. And I know it is a paired t-test because it says that the 21 subjects worked both with the scented and with the unscented. So it's the subjects are the same. Subjects are the same. Okay, subjects are the same for both groups. Okay, now we need to define our variable. So we have mu u, which is the unscented average time, and we have the mu f, which is the floral average time. Now we have, what we really care about is the difference. So the mu d, we'll call it unscented minus floral. All right, so let's take a look at our hypotheses now. The null hypothesis is that the mu d equals 0, and the alternative hypothesis is that the mu d what? So my guess, right, what I'm trying to test is that floral works better than unscented. In other words, this has a higher time than this, which means this number should be positive if I'm correct. In other words, if floral is better than this, then floral should have a smaller number than unscented, so this d should be a positive number. So I want to say mu d greater than 0. Right? I now want to verify the conditions. They tell me it's a random sample is stated, independent trials among the 2 situations, and since n equals 21, we must draw a box plot. So let's draw that box plot. So remember, the way to draw the box plot is to put all the data in and do one variable statistics. I did that. So for the unscented, here's what we had. This is 31, 37.5, 48, 60, 88. And this is skewed right because this distance is 40 and this distance is only 17. Skewed right, no outliers. And then floral, the next page. Floral, of course, we are here. This is 28, by the way, this is floral. $39, $51, $55, $84. This is right skew with 84 as an outlier. So, okay, I'm going to say despite both distributions, so despite both distributions being right skewed, data is symmetric enough for paired t-test. All right, now the math. So we have that our t-stat equals, so this is now we're going to run a one sample test on the data, right? Because we really only have the difference. So x bar minus, this is the null hypothesis, remember, was 0. This right here is s over square root of n. We get those from the calculator. What we end up getting is 0.4416. Again, the way you do this is you plug in list 1, unscented, list 2, floral, list 3, unscented minus floral, and then run the t-test on that third list. P-value equals 0.3332, alpha equals 0.05. Let's draw the picture. So the picture is, we have this situation happening, 0.332. No, this is not 0.332. Remember, this is the t-stat, which was 0.4416. This right here is 0.332. And I'm going to say, since p-value of 0.332 is greater than 0.05, we fail to reject null hypothesis, and we conclude there is not statistically significant evidence of floral scent improving performance, and there you go. That's how you do number 5, a paired t-test.